Alright, welcome back everyone. We're going to spend the next couple of days working on scatter plots and working with lines of best fit. Today we're just going to do the real basic introduction stuff. We're not going to get into a lot of application, just kind of the basics of what a scatter plot is, how to draw the line of best fit, and how to come up with the equation of that line. So a scatter plot is a series of data points that are not connected, and so we're usually talking about survey data or something of that nature where you're trying to compare two different variables, and so you're just randomly plotting the dots. You don't worry about connecting the lines. It's just a random collection of dots, and you can see a scatter plot below here. And a line of best fit is a line that we draw in that we feel is as close as possible to that data. So therefore, you see that they've drawn a red line here on our graph, and that red line represents the best line for that data. It's as close to all the dots as possible, and as you can see, a lot of dots are a long ways away from that line. That might be the case. We're trying to draw in our best predicting line. And as we do this, one of our big goals here is we're looking for correlation. Oftentimes people use scatter plots when they're doing research and they're looking for a correlation or a pattern in the data. They're looking to say, do these two variables relate to one another? So that's what we're looking at when we're talking about correlation, is a pattern in the dots. And we say there's a positive correlation in our data if we recognize that as the x value increases, the y value increases. An example of that would be if you did a survey data of shoe size versus height, you would probably find that people with larger feet tend to be taller, and so as the shoe size increases, the height of the people increase, and so that would be a pattern or a relationship. So that's what we're looking at when we're looking at correlation. Do you feel there'll be a pattern between those two pieces of data? We do a little bit of research and we find out, is there a relationship between shoe size and height? And in most cases, yes. The person with the larger shoe size is also taller. A negative correlation represents a situation where as x increases, y decreases. And so this would be an example of something like maybe an adult tracking their weight as they are gauging how much they work out. So they might say how much they worked out for a week and then their weight loss or something of that nature, where the longer they work out, the less they would end up weighing. Their weight would go down. So as x increases, their weight would decrease. So that would be an example of a negative correlation. And finally, some data has no correlation. If you go and you do a bunch of research and you gather a bunch of data and you end up with a scatter plot that are just a bunch of random dots all over the place, that would be an example of no clear pattern in the data. And so therefore we say there's no correlation or no significant correlation. So an example of that might be something like comparing height versus intelligence. Well, I feel strongly that taller people are probably smarter, but if you did track that out, you'd probably find out that your height doesn't really impact intelligence at all. So you would have dots all over the place. You'd have some tall people with very high intelligence, some tall people with very low intelligence, some short people with high intelligence, some short people with low intelligence. They're kind of all over the map. In that case, that would tell us there's no correlation or no real pattern in our data. So let's look at an example here. This is just a random set of data, and we're not going to connect it to any real-world connection today. We'll get to that tomorrow. But as we're looking at data here, and we're going to come up with an equation of a line of best fit for our scatter plot. When we first go ahead and plot the points on the grid, we hopefully recognize right away, we should recognize there's a correlation in our data. Our dots, as x increases, as x goes to the right, our dots appear to be getting lower, or our line would fall as we go from left to right. So therefore our data is going to have a negative correlation in this case. So if we went in to draw the line of best fit here, what we would want to do is we would go ahead and want to create a line to the best of our abilities that comes as close as possible to all of our data points. So we might end up with something that looks like this. That would be an estimate of our line of best fit. There's a couple dots above it, a couple dots below it. It goes through a couple of dots. That would be our best fitting line. Now, what we're doing here is estimating. This is not an exact science. Now, there is an exact way to go about doing this with computer or calculator calculations, and we'll get to that later, but for right now, all we're doing is trying to draw a line that comes as close to representing our dots as we can. So now we need to go about having an equation of that line, so we can have a rule that would allow us to predict in the future. And so what we're going to do is we're going to look here and we're going to try to come up with 2 points our graph goes through. And now if this were on graph paper, it would be a lot easier, but I went ahead and just kind of estimated and said it looks like our line goes through this point, -2 comma 4, and the point 2 comma 0. So for the purposes of writing our equation of our line, we're going to use those 2 points. Those are 2 points on the line, and you notice they are not points that are in my data set. They don't have to come from your data set. We're looking for points on our line of best fit, not necessarily from the set of data, so it does not matter that they're not in the data set. So we have 2 points that fall on our line, and we want an equation to predict based on our data set. In order to do that, we simply take those 2 points and do what we've been doing for the last few days. We want the equation of the line going through the points of -2, 4, and 2 comma 0. We calculate the slope, and we recognize that y goes from 4 to 0, so that's down 4, and x goes from -2 to 2, so that's up 4. So therefore our slope is -4 over 4, which is -1. Then we go ahead and just do exactly what we've been doing. We plug into our equation y minus y1 equals m times x minus x1. We plug in, we distribute, and we solve, and we have an equation for our line of best fit. To begin with here, we're just doing straightforward calculation. We're not going to spend a lot of time early on here on situational awareness and figuring out what is going on with the scatter plot. We just need to be able to do the calculation. Graph the points, draw in a line of best fit, write the equation of that line of best fit. Tomorrow we'll get into using that information. So tomorrow in class you'll be doing a lot of graphing scatter plots, coming up with a correlation, and plotting those points and drawing your line of best fit. So we'll see you tomorrow.